Okay, so in yesterday's video, we briefly went over, we started section 9.3, but we only covered proving that a quadrilateral is a parallelogram. So today we're going to be moving on, and we're going to take a look at rectangles. So when we're proving something is a rectangle, we have to show that it's a parallelogram first, and then we use the slope formula to prove that there is a right angle, right? And then if we wanted to move on and do a square, we would show it as a rhombus or a rectangle first, and then we would either use the slope to prove it's a right angle or use the distance to show its two consecutive sides are congruent. So we'll go over that more when we get to a square proof, but for now, let's worry about rectangles, and we need to know show it's a parallelogram by any of the means possible, and then use slope to prove that it is a right angle, okay? That there is a right angle. Alright, so let's take a look at our first rectangular problem that we have here. So we have quadrilateral ABCD with vertices A, B, C, and D. And we have to prove that this is a rectangle. So one of the ways that we said, first of all, we know we have to prove it's a parallelogram first, but one of the ways we said we could prove something is a parallelogram is use the slope formula to show that opposite sides are parallel, right? And now we know that to prove something is a rectangle, after that we can use the slope formula to prove that there's a right angle. So in my head, the easiest way to go about this is to just use, when you see rectangle, use the slope formula on all the sides, not only to prove that opposite sides are parallel, but then to also prove that there's a right angle. Alright? So let's start. So we have to show the slope formula on each side. So why don't we start with AB right here? In blue, we know that A is 2, 3, and we know that B is 10, 3. So slope, rise over run, AB, M is equal to 3 minus 3 over 10 minus 2, and that gives us 0. Alright, now we look at BC, and C is at 10, negative 1. So BC, the slope is negative 1 minus 3 over 10 minus 10. But that is undefined, right? Because you can't have 0 on the bottom. Moving on, right here, let's look at CD. Alright, and we know that D is 2, negative 1. So CD, we have negative 1 minus negative 1 all over 2 minus 10, and we get 0. And then for AD, which I will put in purple, let's do AD right here, we will have negative 1 minus 3 over 2 minus 2, but that is also undefined because we end up with 0 on the bottom, right? So simultaneously, we proved it's a parallelogram, and we also proved that it is a rectangle at the same time. We needed to do both those things, and we got to bang it out all in one step, right? Because we proved both that there was a right angle and that opposite sides were parallel. So all we have to do is say quadrilateral ABCD is a rectangle because opposite sides are parallel, and and right angles are formed. Alright, and that's it. So these are pretty straightforward. You just have to know when to use which formula, and as long as you have your notes with you that tell you exactly what to use, you'll be fine. You'll be able to solve any of these, okay? Alright, moving on. Okay, so looking at this next problem we have here, we have to prove that ABCD is a rectangle, and we're going to go about this the same way as we did the last one. We are going to do the slope of every side of this quadrilateral to show that there are right angles and also that opposite sides are parallel. Okay? So let's start with AB. I know this is a little hard to see. Right here we have AB. And A is -3, -1, and B is 6, 2. So for AB, to find the slope, we have rise over run. So 2 minus -1 over 6 minus -3, and we get a third. Okay, so looking at BC, which is right here, this is C, and C is at 5, 5. So BC, rise over run, will be 5 minus 2 over 5 minus 6, and we get -3. And now let's look at CD in the green here, and D is at -4, 2. We get 2 minus 5 over -4 minus 5, and we get 1/3. And then finally, let's look at AD right here in purple. So for AD, we'll get 2 minus -1 over -4 minus -3, and we get -3. And so we showed that opposite sides have the same slope, right? Proving it's a parallelogram, because AB and DC have the same slope, and AD and CB have the same slope. And they're also negative reciprocals of each other, which proves that they are right angles. So that's all we have to do. So all we have to say is quadrilateral ABCD is a rectangle because opposite sides are parallel, and right angles are formed. Alright, that's it. Okay, so now moving on, we have to prove that this quadrilateral is a square. So what I'm going to do, remember we have to prove it's a parallelogram, prove it's a rhombus or a rectangle, and then do one more step to prove that it's a square. So there's a lot more work for squares. These are going to be a little more than any other problems that we have to do. Just because of all of the properties, it has so many properties in a square. So first I'm going to prove that it is a rectangle and a parallelogram at the same time. And to do this, I am going to use a slope formula to prove that there is a right angle and also that the opposite sides are parallel. So that'll knock out both those things with one step. So that'll be the slope formula. So why don't we start with AB right here. So AB, rise over run, we'll have 5 minus 1 over 1 minus 4, and that gives us -4/3. Then BC, right here, rise over run will be 2 minus 5 over -3 minus 1, we get 3/4. And then look at CD. -2 minus 2 over 0 minus -3 gives us -4/3. And finally, AD right here will give us -2 minus 1 over 0 minus 4, and that is equal to 3/4. So already we know that it is a rectangle because these answers show us that opposite sides are parallel and there are right angles. Okay? Now because we proved it's a rectangle, our next step is to use the distance formula to show that two consecutive sides are congruent. So that's it, and then that'll prove that it's a square. So let's start with why don't we start with AB again? We'll do the blue. We'll keep that going. AB. We have to do the distance formula. So it's going to be the square root of 5 minus 1 squared plus 1 minus 4 squared. We get square root of 25. Oops, 25. And that gives us 5. And then if we look at BC, we'll get the square root of -3 minus 1 squared plus 2 minus 5 squared, which gives us square root of 25, which gives us 5. Then if we look at CD, square root 0 minus -3 squared plus -2 minus 2 squared, which gives us 5. And last but not least, for AD, we'll get the square root of -2 minus 1 squared plus 0 minus 4 squared, which is, again, 5. So that's it. That's all you have to do. That shows it's square. All we have to do is write our concluding statement, which will say that quadrilateral ABCD is a square because consecutive sides are congruent and perpendicular. Okay? And that's how we prove a square. Okay, so moving on, this is going to be our last problem for today. So we have to prove that EFGH is a square, which means first we prove it's a parallelogram and a rectangle. So to do that, I'm going to do it the same as I did last time. I'm going to prove that I'm going to use the slope formula and prove that opposite sides are parallel and also right angles are formed. So I'm going to start with EF, which is right here, if you can't see. It's a little light. So E is at -7, 0, and F is at -2, 0. So what we have to do for EF, 0 minus 0 over -2 minus -7, and that gives us 0. Alright, moving on. So that was EF, so now why don't we do FG right here. This is G, which is -2, -5. So to do the slope of that segment, we will do FG, -5 minus 0 divided by -2 minus -2. And because we end up with 0 on the bottom, that is undefined. Okay? Next, let's look at HG right here. Here's H, which is at -7, -5. So HG it will be -5 minus -5 over -7 minus -2, which gives us 0. And finally, we look at EH. -5 minus 0 over -7 minus -7 is undefined. Okay? So this tells us that it is a parallelogram and rectangle. Right? So moving on, now we have to use that and prove that it's a square. So our last step is going to be use the distance formula to show that consecutive sides are congruent. So let's start with EF again. EF. Use the distance formula. We'll get square root of 0 minus 0 squared plus -2 minus -7 squared, which gives us square root of 25, which gives us 25. Okay? And then if you are forgetting any of these formulas, slope, distance, anything like that, I went over them in yesterday's video. I don't want to do it again and waste your time if you already know them. So if you are looking for these formulas, you can either look them up online or you can go and look at yesterday's video, which is 9.3, proving parallelograms and rhombuses. Okay? Okay, so we did EF. Now let's look at HG. Let's look at FG. Let's look at HG. Okay. So HG will give us a square root of -7 minus -2 squared plus -5 minus -5, and that gives us square root of 25, which gives us 5. I messed up over here. This was supposed to be 5. Just realized. Okay. So we know that already those two segments are congruent. So moving on, let's look at FG. So that we'll look at square root of -5 minus 0 squared plus -2 minus -2 squared. We get the square root of 25, and we get 5. Last but not least, HE. Square root of -7. Sorry, was looking at the wrong one. HE will be -5 minus 0 squared plus -7 minus -7 squared, which gives us 5 again. So we have 5 for all values, for all side lengths, which means that all side lengths are congruent, and we are done. All we have to do is write it out. Quadrilateral EFGH is a square because consecutive sides are congruent and perpendicular. Alright, so that's it. You have everything you need. My advice is to keep your notes handy, and right at the beginning of section 9.3 it tells you, it breaks down every possible way to prove any of these shapes in a coordinate plane. So if you have that, follow those steps and you'll be fine. Okay? And again, there's a Google Forms attached for these as well.